This is part 15 in a series of videos in which I am repairing and restoring a number of Intel MDS systems. In this video we'll be looking at this, and this is of course the floppy drive from one of the MDS units. It's an 8-inch drive, it's a Shugart 801, and I've been going through the electronics, repairing that first just to make sure that they were actually repairable. They all had faults of one form or another. This particular one had a shorted capacitor on the 24 volt power rail, and it also was reading open circuit on the read-write head, and luckily that just turned out to be a broken wire at the head end of this cable. So the next step is to sort out the mechanics in this drive. In this video I'll be showing how to replace the bearings, both the head bearings and the main motor drive bearings. The arrangement in the MDS is a bit unusual in that this drive runs all the time the machine's powered up. The drive motor is wired directly across the mains, so as soon as you power up the machine, the drive motor starts up and it spins for as long as the machine is running. And in fact, as long as the drive door is closed, if there's a disc in, then the disc is spinning as well. It's not a very good arrangement. It is possible to modify these so that the motor only runs when the head is loaded, but that's not how these are arranged. They run all the time, and the bearings do wear out relatively quickly, especially those in the motor, because the motor does run quite hot. So in this video we'll be looking at replacing the bearings. And what I'll do, I'll just move the microphone closer to the drive so you can hear it. So hopefully you could hear that. The bearings in this particular drive are in a very poor state. So I'll be replacing the bearings in both the head and the motor. And step one is to get the board out of the way. So I'll remove the board and we'll be able to then see how to remove the motor and the main head. So disconnect the read-write head, and we remove the screws holding the board in place. I've removed all except for two already. And now the board's loose, we can just move it forward very slightly and disconnect the two remaining cables. Okay, and that's the board out of the way. And the next step is to get the belt off, and that's very easy. Just spin it round, easy to cross slightly, and it will come straight off. And we'll get it out of the way. As I said in a previous video, to inspect these, just look for any nicks or excessive wear, and make sure no part of it is stretchy. If any part is elastic, then the belt will need replacing. They're very resilient belts, they do tend to last a very long time. There's a lot of corrosion on these pulleys as well. That will need to be cleaned off, because that will wear the belt out quite quickly. We'll start at the main head end, and step one is to get this pulley off. Should come off fairly easily. As you can see, there's quite a lot of corrosion on the nut on this one, so just hold the pulley still. The nut should undo fairly easily. So in this case the entire shaft is spinning round. But if you just, what I'm doing here is I'm twisting the pulley very slightly, and it will kind of nip the shaft and stop it rotating, and then that allows me to take the nut off. And before you get the nut all the way off, just ease the pulley forward. And having the nut on will prevent the pulley flying all the way off. So then take the nut all the way off, and we should now be able to pull this pulley all the way off. Okay, and so just ease the pulley all the way off. Make sure that you don't rock it or tilt it excessively, because you can bend the shaft. And what I'm doing here is just rocking it gently from side to side, and eventually it will come off. Okay, and so what you end up with is, you can see the lower bearing. There are two bearings, there's this one and the one at the top. And so the next step is to take this shaft, and it needs to be pushed all the way through in the opposite direction. So we take this cover plate off. If you're going to strip the entire drive down, you can just take this entire top section out. I will probably have to take this out on this drive because it's in such poor condition, but normally I wouldn't do that, so I'll show how I normally go about doing this. And that is just to take this cover plate off. And then what you can do is pop this out of the way so we can see what we're doing. So what we have is this portion of the drive, and what we can do is obviously push that through from the other side. So these vary a lot. Some are easy to get out, some are very difficult, but what I normally do is put the nut back on, and I start by just trying to press it through. If that doesn't work, I will very gently heat the casting with a hot air gun, and that's normally enough to free it up or expand it a bit so that the bearing will push out. But in this case, as you can see, it just pushed through, and what we've done is we've pushed the drive through to the other side. And what I can now do is take the nut back off, and then once we've got this freed off, so now we've got it moving freely, the next step is to take the front cover off, or at least loosen it, so that we can raise this part of the drive, and then we can lift this all the way out. So what we need to do is you can either take it off here, or you can take the front cover off. Depends on how far you're going to dismantle the machine. Now I'm going to take this front cover off anyway, but what you can do if you want to save a bit of time is just take these two screws out here. But I'm going to take the entire front cover off. Okay, that's the front plate out of the way. The next thing is to lift the spindle all the way out. So to get it out, you just need to raise this part. Don't go too far with this because you don't want to overstress the helical spring that controls the head pad, the head pressure pad, otherwise you can end up having read or write problems. So just take it far enough until you can pull the spindle all the way through. Now that we've freed it up, it should come out fairly easily, and then we can put that to one side. Next thing is to take out these two screws. So what we have are two bearings. There's a flanged bearing at the top, a spacer, and then a plain bearing at the bottom. So the easiest way to get this out is to take these two screws out first. We should then be able to lift the flange bearing out, and then we can push the lower bearing out through the bottom of the drive. So I've now removed the two screws. We should be able to pop this top bearing out. If you intend to reuse it, you need to be fairly careful how you get it out, but as I'm going to replace these with new ones, then it's not particularly important how I treat it. Notice there is some corrosion on this, so it's well worth replacing anyway. So the easiest way I found to remove these is to find a drill that fits in the centre of the bearing, and then you should be able to just very, very gently rock it, and it should come out. Don't tilt it too far, you'll damage the housing, but it should be possible to work this bearing out, and it should slowly come up as you rock it side to side. If this doesn't work, then what you can do is drive it through from the other side, and it kind of depends on how tight the bearings are. Okay, and eventually it will just pop all the way out. And this one does feel quite bad. Okay, and the next thing is to get the spring and the spacer out. So take the spacer out, and then the same with the spring. There's quite a lot of debris in there, so this will need cleaning out as well. And then what we have is, you can see the bearing right at the bottom, and so all we need to do now is to just gently drive that down with some sort of drift. Okay, so Very occasionally you'll come across drives where the bearings just will not come out. They're absolutely seized in place, and normally that's a result of them being put in not quite square. And I repair an awful lot of these drives, so I've made up tools over the years to help me with each type of drive. So if you really can't get the bearings to move with just the methods that I've shown here, what you can do is you can make up some special tools. So I have a kit for each type of drive that I repair, so new bearings, drifts, etc. Now normally it should be just sufficient to try a drift and to gently tap this through, but it is literally very gently. If you start having to hit it too hard, then you need to take a different approach. And so what I've done in the past is made up pullers, and the way this works is to sit on this outer face. So there's a recess in the bottom of this, and this sits on this outer rim, and what you can then do is put a threaded bar through the center, and because the bottom bearing is plain, it will actually come up through the entire channel. And the way this normally works is you have this, of course, and then the position of this is controlled by the flange on the top bearing. So this will sit on here, and then this, as you saw, the top flange is held in place with some screws in the top of this recess. You then have a spacer, and the bottom bearing sits on the bottom of this. So the bottom bearing is it floats up and down, so as this heats and cools it doesn't bind up, and the bottom bearing can move slightly. That's why normally the bottom bearing is quite loose, because it does move slightly up and down as the drive heats and cools. So normally when you take this out it will just fall out. But what you can do, of course, is replace this part with the threaded bar out of the puller kit that I've made. That then comes through from the bottom on the outside of the lower bearing. This sits on top, and then when you put another washer and nut on top and start doing a nut up, it pulls the entire assembly up through the tunnel, and then by the time it's moved this distance, this will just pop out. You can then do the reverse and turn the whole thing around, put this the other way up on the bottom, and then pull the entire assembly back down through the bottom. But normally it is sufficient, as I said, just to tap it out. So this is a Delrin rod, so it's a bit of plastic, so it doesn't put too much force on anything, and you should be able to very gently tap this through. Now I can feel it moving. I'm not hitting this very hard at all. You can see it's going down with just gentle taps, and then as I'm driving it through, the lower bearing is being driven out. You can see there's corrosion on the outside of this, why it's not just fallen out, and also because it hasn't been used for a long time, then it will be tighter. But it's just being very gentle with it. If you're having to use too much force, then you need to go to a puller and to start heating up the housing very slightly with a hot air gun. But you can see that took almost no force, and the bottom bearing is now out. We will need to clean this tunnel. There's a lot of debris and muck in there, but I'll do that when I come to reassemble it. The tools that you make up depend on what you have to hand, but I do find that if you're going to do more than one or two of these drives, then it is advantageous to make up some pullers for getting these bearings out. Okay, so that's the main head. We'll come to reassembly later. Next thing is the drive motor. So the first thing to do with the motor is to disconnect the wiring. You can do this with the motor still connected, but it's just far easier to take the motor off completely. So step one is to pull the terminals off the filter. That's the first one. And then the second. And then of course you have the awkward one, which is the one that goes into the connector. And with these connectors you can remove the terminals. If you look down inside, you can see there's little fingers that spring out when you push the contact in. All you have to do is push the finger back in very gently, and then the pin will pull out from the rear. And so the easiest way is to take a small screwdriver, find the finger that's holding it in place. You probably can't see this on camera, but I'm pushing in the little tab that's holding it in place, and then you should be able to pull the connector out through the back of the housing, and then we can remove all the wiring. Next thing is to remove the motor from the chassis. So if we turn it over, you can see that the way this is held in place is we have this screw goes through the motor and holds the motor together, and then there are screws on the bottom that hold the motor to the chassis. So I want to take these screws out. And once we've got all 4 screws out, we can just lift the motor off the chassis, get the chassis out of the way, and then next step is this will depend on exactly which particular motor you've got, but I tend to find that you're going to have to take this fan off anyway, and these bearings definitely changing, they're quite noisy, so there's a small grub screw that you need to take out. Be careful not to nick or damage this pulley, because if you end up with any sort of spikes or burrs on it, then you're going to very quickly destroy the belt. So I'll just get this pulley removed, and all I'm going to do is loosen off the grub screw, and then I'll try and pull this off. If it won't come off, I'll get back on camera and show various ways of getting these off if they're too tight. Okay, so what we have to do is remove the grub screw, or at least slacken the grub screw that's down in this recess. Now whenever you're working on old equipment like this, it's well worth spending time on each step, making sure you're doing the best you can to avoid damaging anything. Not just because of the nature of the machine you're working on, but also to save yourself a lot of time. Now, one piece of advice I'm going to offer that I wish I'd been given many years ago was, if you're going to buy something like Allen keys, don't buy one set, buy maybe 3 or 4 sets, but from different suppliers. So I've got 2 Allen keys here. They're both supposed to be exactly the same size, but of course, as with anything, you get tolerancing, and especially with small components that have been in for a long time that could be quite tight. If I, for example, put this Allen key and I engage it with the screw at the bottom of this, you can see there's quite a lot of slack, and the danger is if I just try to undo this screw now, this set screw in here, and it rounds out, then I've got a major problem now trying to get this off, and of course that could take many hours of work and may even mean I'd have to make a new pulley up. So I've got probably quite a few different sets of Allen keys, so I wouldn't try and do this particular grub screw with this this Allen wrench. It's too slack. It might do it, but it could just round it out. It depends on how tight it is, the quality of the material the screw's made from. So what I do is I go through the sets and I try and find one that is a tighter fit. This is just tolerance. This is the same size. It's meant to be the same size. If I put this one in, you can see that there is a bit of slack, but nothing like we had on the other one. So if I rock this side to side, you can see there's probably 10-15 degrees. If I put the other one back in, you can see, although it's meant to be the same size Allen key, there's a lot of play, and because these are so small, then of course it doesn't take much to round out the screws. There's no guarantee this will take it out, but I've certainly got more chance with this one than with the other one, and that is quite tight in there. Okay, so that's loosened it. I think the other one almost certainly would have rounded out, if not the screw, then certainly the Allen key itself. So this should not be very tight on here. What you can do is just hold on to it for a minute or so. It'll expand, and it should loosen it enough so you can pull it right off. That should be long enough, so that should pull off, which it does. Notice also this is curved, and that's to make the belt self-center. So most things like this are quite easy to deal with as long as you take reasonable steps and don't rush it. You'd end up just making a lot of work for yourself, and what should be a 5-minute job can take hours. So we take the pulley off, and we should now be able to slide this plastic pulley off the motor shaft. And again, it's really a case of working it slowly back and forth until we get it off. So it can take a bit of time to wiggle it back and forth, but as I say, it's better doing it this way than applying too much force. You can see eventually it will come off, because otherwise this is just plastic, and if you break it, then you've got a big problem trying to find something that you can replace it with. So that will eventually come off. It's not keyed, it will go on any way round, but the main thing is don't break it. Okay, so we've now got the motor free. There's nothing now to stop us taking the motor apart and trying to get the bearings out. Okay, so I found a screwdriver bit that's a very good fit in the head of these screws. Before we start taking them out, I just want to make sure I can reassemble this the same way. So just a couple of dots so we know which is which, and if we do two at one side, we know which way around it went on. We can always remove those with a bit of IPA later on. And so now we take the screws out. They shouldn't be too tight. Okay, so now we've got to this point. We want to get the motor rotor out, and these wires only connect to the stator, so these are just connected to this part. What we need to do is get the two end caps of the motor off. Now there may be some wavy washers at each end, so we need to make sure if there are that we put them back in the same position they came out, otherwise you might find the motor will rub when you reassemble it. And also, as you take this apart, you'll need to feed the wires through this hole into the motor, so you don't pull them too hard on the inside. If you just try and rip this off, you can tear the wires off that connect to the stator windings. So these should not be very tight, and again, it's a case of if you've got to do anything very hard, then you're probably doing it wrong or something's stuck. So they should just come off very easily. Once you've got one off, you can leave the other one in place, tilt it on its back in case there are any wavy washers in there, then you should be able to just lift this out, and then you've got this out of the way. I believe these are 608 size bearings, and you can get ceramic versions of these bearings, which is the ones I normally fit, because they are much better quality than the steel ones. They'll last a lot longer. If you want to, you can, these are ZZ type bearings, so they've got clipped in steel dust covers. You can pop those out, flush them out, re-grease them, and put them back in, but I won't be doing that. I'll replace them with new ones. And so to get these off, they're normally fairly tight, so what you'll have to do is in general use, I find the easiest way, if you've got a lathe, is to clamp these in the jaws of the lathe, and then just put this in the tailstock and pull it out with the tailstock by unwinding the tailstock. It will pull out fairly easy. That's what I'm going to do with this. If you don't have that, you'll need to figure out some other way of doing it, and if you really can't get them off, just pop the dust caps off. This thing's waterproof, you're not going to do any harm to it. Pop the end caps off, immerse it in something to clean them out, and then re-grease them, and you can put them back on without having to remove them. So that's the easiest way of doing it, but I'm going to take these off and put new ones on, and what I'll do is I'll go and get these off on the lathe, come back, and we'll have a look at fitting the new ones and then fitting the bearings to the head as well. They are different sizes, they're not the same size bearings on the head and the motor. These are the head ones, and as you can see the motor ones are significantly bigger. Okay, so I'll go and get these bearings off and then get back on camera and we can start reassembly. Before I do that, I just want to point out that what I was talking about with the wavy washers, these are to stop this thing wandering up and down. They push it one way, but make sure you put them back where they were. Sometimes there's more than one, but make sure they go back in the position that they were in. Okay, so I've got the bearings removed from the motor. It did occur to me when I was doing this that maybe not everyone has a lathe, so perhaps the advice I gave wasn't quite the best. If you don't have a lathe, another way of getting these off is quite simple. They are quite tight on the motor, so you will probably need to use a drift or something to get them off. The easiest way of doing this if you don't have a lathe is with the bearings on the motor is get a couple of Allen keys or small spanners You need two on either side, and then what you do is you hook them under the bearing like this and then rest it on the open jaws of your vise, so the vise is open just far enough for this to sit in between. So if you imagine my thumb and fingers are the jaws of the vise. Space them out to make sure that they're not sitting, there's a spring clip underneath, so make sure they're far enough apart so they're on the outer race of the bearing. And then what you can do is just get a brass drift, put it on the centre, tap it, and it will push the motor shaft right out of the bearing. So in other words, these are sitting on the vice jaws and the motor's just hanging, and you can knock it through. Be prepared to catch the motor, don't drop it on the floor because it's aluminium casting and these will smash. And then you can just knock it through. They'll come off extremely easily if you do it that way. So once you've got them off, you can either take the covers off. These are quite bad, so I'm not going to even bother trying to lubricate these. Didn't really feel the roughness in them. As I say, they're 608 size bearings, so they are fairly standard size bearings, as are the bearings in the head. I always keep quite a few of these to hand. Like I said, I do quite a few of these, so I've got the bearings ready to go straight in. And as you can see, if I spin this round, it's nice and free. If I try the same thing with one that's come out. Okay, so next thing we have to do is refit these. Lots of different types of these bearings around. Like I said, if you want to use, these are ceramic, so if you want to use bearings like this, then it really does improve the quality of the motor. Or you can just put standard steel ones in, it doesn't really matter. So what I'm going to do is go back to the workshop, press these back on. Now of course pushing them on is a lot easier than taking them off, but just be very sure that they go on squarely. If they start to tilt, then stop and take them off and try again. Also, don't press the outer race, and make sure you only press the inner race. So I'll get these over to the workshop, I'll get them pressed back on, and then we can fit the rotor back into the motor. Okay, so I have the bearings fitted back onto the motor, much better than the old ones, and we can now reassemble the motor. So it's just simply a case of dropping the rotor, make sure it engages properly with the end, and you should be able to feel the springy washer, which I can. Find our registration marks. Just going to clean this out. Okay, just giving that a bit of a clean, it was a bit dirty. And then this should just fit down, engage with the bearing, and then relatively easily push down into place. And we can now refit the screws and reassemble the motor. If you find that as you're tightening the screws something feels to be binding, or the shaft doesn't spin freely, take it back apart. Something's not right. Don't just keep tightening down on the screws, something will get damaged. Okay, and we should find now that the motor will spin nice and freely. This is much better. And what I'll do now is I'll go and clean the fan. We can refit this, refit the pulley, and then the motor is ready to go back into the drive. Okay, so I've cleaned the fan, that's ready to refit. And same with the drive pulley. I have cleaned all the burrs off this. It still looks fairly corroded and pitted, but it's actually quite smooth, and it's just a matter of lining up the grub screw with the flat on the shaft, and that should push all the way on. That's the pulley refitted to the motor. I'll just tighten the grub screw. It does not need to be horrendously tight. And I'll now refit the motor to the chassis. So it's just the reverse of removal. Just make sure you get the wires facing the right way. Okay, that's the motor refitted. Next thing, I'm going to clean out the recess. Again, being careful not to raise this arm too far. I will be taking this arm off, but I'm just trying to show how I'll do it without having to remove the arm. And then once those are clear, once that's cleaned out, the next step is to get your new bearings, and we start off with the flange bearing at the top. So this is the flange bearing. Pop that down into position. Then we refit the two screws that hold this into place. And tighten these down evenly in case the bearing's not yet all the way in. But as I say, they do not need to be horrendously tight. Okay. Next we clean this up. So that's now nice and clean. Pop it back in through the bearing. Turn the drive onto its side. Take the spring, the spacer, and then we get the plain bearing. Okay, and that goes onto the shaft. And what we do now is the spacer, if we try and push this bearing all the way, it won't go quite all the way in, and that's because of the spacer is the correct length. So there's about 1/2 mm gap between this front face of this bearing and the housing when it's pushed all the way in, and that spacer inside is what separates these two bearings. This bottom bearing is designed to be floating. So the next thing we have to do is refit the pulley. Before we do that, I need to clean some of this corrosion off. It is a bit too bad on here, and I am going to take this over to the lathe and very gently skim this surface. It's very badly pitted, and that will wear the belt out very quickly. And also that's not something that we want to do. There's no point replacing the bearings if we then destroy the belt. So I'll take this over to the workshop, I'll reface this, and then I can refit the pulley, and then we can refit the belt. So I've machined the outer rim of the pulley. It's not something you'd normally need to do, but because this was so badly pitted, it was the easiest solution. I've taken about a 1/50th of a millimetre, so it's very little material, but it does obviously give a nice smooth finish. If you don't do that, you can end up destroying the belt, and it really depends on the condition the pulley's in, but most of the time you don't need to do that. So we can now do the final part of the assembly, refit the pulley, make sure the bearing is inside the housing, support the rear of the shaft, and then you can fit the pulley, and you should feel the bearing go up inside the housing against the spring, which we can. Refit the washer, and then finally refit the nut. And then all we have to do, retighten the nut. Again, does not need to be horrendously tight. Let's get that out of the way for now. And then the final step is to refit the belt. And that's it. And that horrible grating noise has gone away. All we're hearing now is the belt going around the pulleys. And of course it's spinning much more freely as well. So that's all there is to swapping these. It will also quieten down as it's run. Once it's been run for a while, then it'll get even quieter once the bearings have settled down. The bearings don't need changing all that often, probably every 1,000 hours or so, but it does make a big difference to the operation of the machine. Gets rid of that horrible grating noise that comes from it. And it's as simple as that. Without stopping for all the filming, it would have taken probably half an hour, so it's not particularly time consuming. So the bearings you need are standard sizes. These are R422s for the head. You need two types. You need a straight one and one with a flange. And but as I say, they are standard sizes, so quite easy to find. And you also need some 608 size bearings for the motor. I used ceramic, but you could use ordinary steel ones. And it's as simple as that. It's just a case of swapping the two out of the motor, swapping the two out of the head, and it's as good as new. I'll finish reassembling this off camera. There's some more work I have to do. There's some damage to the front panel, and then I'll get this reassembled and cleaned. I can then refit it to the MDS. Any questions, then please leave a comment.